All right, let's jump right into a topic that's pretty much the foundation of all geometry: lines and angles. We're going to do a super quick revision, breaking down all the essential rules you absolutely need to know, and we'll start right from the very beginning. So, what's the game plan? Well, we'll kick things off with the real basics, points and lines. Then we'll just keep adding layers, one concept at a time, until we're ready to tackle problems with triangles. Ready? Let's get started. Okay, first things first. Before we can even get into cool stuff like angles and shapes, we've got to nail down the fundamentals. Think of these as the basic Lego bricks of geometry. All right, let's start with a super simple one: the difference between a line segment and a ray. A line segment? It's got two endpoints. It's finite. Think of it like a ruler. It has a clear beginning and a clear end. But a ray? That's different. It has a starting point, sure, but then it just goes on forever, in one direction, kind of like a laser beam. So what about when you have a bunch of points hanging out together? Well, it's pretty straightforward. If you can draw one single straight line that hits every single one of them, we call them collinear. But if they're all over the place and you can't connect them with one straight line, then they're non-collinear. Simple as that. Okay, so we've got our lines and rays down. Now let's talk about what happens when they actually meet. And that, my friends, is where the whole world of angles opens up. An angle sounds complicated, but it's really not. It's just the space or the amount of turn between two rays that start from the exact same point. And that starting point, we just call it the vertex. That's it. And this table here is your cheat sheet for every kind of angle you're ever going to see. Think of it like a spectrum. You've got your small, acute angles. Then, boom, at exactly 90 degrees, like the corner of a book, you have a right angle. Go bigger and you're in obtuse territory. A completely flat line is a straight angle at 180. And if you go even further around, that's a reflex angle. This is basically the core vocabulary you need. Okay, pay attention here, because these are two terms people mix up all the time. Complementary angles, they complete each other to make a corner, a right angle, so they add up to 90 degrees. Supplementary angles, they supply the angles to make a straight line. They add up to 180. Complementary, corner, 90. Supplementary, straight, 180. Got it? All right, building on that idea of pairs, let's zoom in on angles that are literally right next to each other. These neighbor angles have their own special rules, and they're super important. So, how do you know if two angles are adjacent? Well, there's a 3-point checklist. 1, do they share the same corner, the same vertex? Yep. 2, do they share one of their arms? Yep. And 3, are there other arms on opposite sides of that shared one? If you can check all 3 boxes, you've got adjacent angles. All 3 have to be true. Now check this out. A linear pair is a really special kind of adjacent angle pair. It's what happens when those two non-common sides stretch out to form a perfect straight line. And what do we know about straight lines? They're 180 degrees. So a linear pair will always add up to 180. No exceptions. Okay, now for a situation you are going to see over and over and over again. What happens when two straight lines just cross each other? You get this classic X shape. And this X comes with a super simple but incredibly useful rule. And here it is. This is the big one. When you see that X, the angles that are directly across from each other, we call them vertically opposite, are always the same. They're equal. Seriously, burn this into your brain. It's a massive shortcut. And here's a perfect example of how we can actually use this stuff. See those two angles, 5x and 7x? They're sitting on a straight line, right? So we know they're a linear pair, which means they have to add up to 180. So you just set up a simple equation. 5x plus 7x equals 180. That means 12x is 180, so x has to be 15. Then you just plug that 15 back in, and you find out the angles are 75 and 105 degrees. See? Easy. Okay, hold on, because this is where things get really cool. We're about to level up. We're going to take parallel lines and slice through them with another line, a transversal. When we do this, it unlocks a whole treasure chest of new rules and relationships. Transversal sounds like a fancy word, but it's not. It's just any line that cuts across at least two other lines. That's all. But the real magic happens when the lines it cuts through are parallel. That's when all the special rules suddenly appear. And this table is your golden ticket. Seriously, just look for the shapes. If you can spot a Z shape, the angles inside the corners, the alternate interior angles, are equal. If you see an F shape, the corresponding angles are equal. And if you see a C or a U shape, those co-interior angles add up to 180. The key is to just look for the Z, the F, and the C. It's a game changer. Okay, quick brain teaser for you. Let's say you have 3 lines. Line L is parallel to line M, and line M is parallel to line N. So what's the deal with L and N? Yep, you probably guessed it. They have to be parallel to each other too. It's a basic rule of logic. If 2 lines are parallel to the same third line, then they have to be parallel to one another. All right, it's time for the grand finale. We're going to take everything we've just learned, all these rules about lines, angles, and parallels, and apply them to one of the most fundamental shapes in all of geometry, the triangle. Here's the thing about triangles. Every single one of them, I don't care if it's big, small, skinny, or fat, follows 2 unbreakable laws. Law number 1, the 3 angles on the inside always add up to 180 degrees. Always. And law number 2, if you extend one side to make an exterior angle, that angle is always equal to the 2 opposite interior angles added together. And this is the really cool part. We can actually prove the 180-degree rule using what we know about parallel lines. You just draw a line parallel to the base of the triangle. When you do that, you create those Z-shapes, those alternate interior angles. And suddenly, you can see that the 3 angles of the triangle perfectly line up to form a straight line. And a straight line is 180 degrees. It's such an elegant proof. And with these rules in our pocket, we can solve some pretty cool puzzles. For instance, think about this. Imagine you have 2 adjacent angles on a straight line. Now, what if you bisect both of those angles, cut each one exactly in half? Well, the angle between those 2 new lines, those bisectors, will always be exactly 90 degrees. It's a really neat outcome that flows directly from these rules. And there you have it, a super fast crash course on lines and angles. So to wrap this all up, I want you to just take a second and look around the room you're in right now. Seriously, look at the corners of your monitor, the edges of your desk, where the walls meet the ceiling. Geometry isn't just something in a math book. It is literally the blueprint for everything around us. Now that you know the rules, where do you see them?